Welcome back, everyone. This video is a continuation of our discussion of some set theory concepts from section 2.2 in Math in Our World. In this video, we will talk about set operations. So, as with numbers, we have things that we can do to combine sets. So if you're talking about numbers, we usually have the operations of addition, subtraction, multiplication, and division. And for sets, we have some new operations which are also a little bit related to those ideas of addition, subtraction, and one that's a little bit different even than the other two, than multiplication and division. Okay, so we have, here we go, different ways to combine two sets. The first set operation is called an intersection. Okay. The intersection of two sets A and B is denoted with this symbol. It's like a little upside down U. I always think of this as like a hoop or a loop from croquet. And this is the set of all elements that are in both sets. So if you think about like a road intersection, okay, here's the intersection in the middle, and this is the only part of those two roads that's actually on both of those roads. Okay. All right, in set builder notation, we say that A intersected with B is the set of all x, such that x is an element of A and x is an element of B. All right, so the key word for intersection is and. That's very important. Intersection means and. All right, in this figure we have two sets. These are shown using a Venn diagram, sets A and B. And the intersection is the place in pink here where the two sets overlap. And you can see that there are two elements that are in both A and in B. The elements 14 and 15 are in A and in B. All right. Now, when you combine two sets, you get a new set as an answer. So when we write A intersected with B, okay, we're combining a set with another set, and you get a set as an answer, so you put your answer in braces because it's a set. All right. Just like if you were adding numbers, you get a number as an answer, you wouldn't have something like, you know, the letter A or something weird like that. Okay, let's practice finding intersections. All right, so we have three sets here, A, B, and C, and they're given, all of the elements are listed, and we need to find each of these intersections. Okay, so A intersected with B. Right. Now, if you wanted to do this the long way, you could recopy out all of A and all of B, and then you would look for the things that are in common in both of them. All right, but here's A and B already listed, so I'm going to kind of shortcut. I'm taking this set and I'm intersecting it with this set, and I'm going to see what elements are in both of those sets. All right, so you kind of just look along. Not 5, because 5's not in set B. Okay, not 0, that's not in set A. 10 works. 10 is in both sets. All right, not 15 because that's not in the second set. 20 is in both. All right, not 25. And then we've run out of elements in A, so I don't even need to check the others in B because I already know that they're not in A, so I'm just going to cross those off. All right, so the two elements that are in sets A and B are 10 and 20. Okay, the intersection of B and C. All right, so I'm looking for elements that are in both B and in C. Okay, so not 0, not 10, not 20, none of those are in set C. 30 is, and not 40. Okay, and I've exhausted the ones in B, so I don't even need to check the rest of the ones in C. I know they're not in B. All right, so 30 is the only one that is in both. All right, and remember, again, I'm not just writing the number 30, I'm writing it in braces because it's a new set. The answer to the intersection is a new set containing 30. All right, and then finally an example with three sets. Yes, you can have the intersection of three sets, kind of like if you had the intersection of three streets. And we'll maybe even make this one curved. Okay, the intersection of three streets is the spot where they all three cross. All right. Notice it's not Okay, now if this is like street A, street B, and street C, okay, I do have another spot where A and C intersect, but because it doesn't also intersect with B, then I don't count it as the intersection of those three streets. All right, so what I'm looking for in this is the set of all the elements that are in A and B and also in C. All right, so let's go through. We'll look for any of those. Let's see. Not 5. Okay, maybe 10. 10's in A and B, but it's not in C. All right. 0, nope, that's not in all 3. 20's not in set C. Okay, 15. Nope, that's not in all 3. 25. And that's it. I've run out of elements in A. So it actually turns out that there are no elements that are in all 3 of those sets. Okay, so what do you think the answer would be? Okay, it's a new set with no elements. It's the empty set. All right, so you can have an intersection of sets that is empty. And if that happens, these sets are said to be disjoint. Okay, they don't share any elements in common. Here's another example of 2 that are disjoint, 1, 3, and 2, 4. All right, because if you look at the intersection of these 2 sets, there's nothing in it. They share nothing in common. This would be like a couple who's dating and they have no common interests. Right, nothing in common. They're complete opposites. That's a disjoint couple. When you look at the Venn diagram, we draw the circles not overlapping, and that indicates that they don't share any elements in common. So if you know for sure that the intersection is empty, you can draw your diagram that way. Okay, so intersection, that's the first of our set operations. The second one is very similar to what we would think of as addition for sets. This is called the union. Here's your symbol. It's like a curved U. It's more straight on the sides though, and it doesn't have the tail like a U. Okay, so A union B is the set of all elements that are in either set A or set B or both. That's okay as well. We don't usually say or both. Notice it's in parentheses. So in math we use what's called the inclusive or. And this means that when you say or, you automatically mean the ones that are in both as well. This is different than in English, where a lot of times you use what's called the exclusive or. All right, so if I say, do you want to go to the movies or for a walk, I'm implying that I want you to just choose one or the other, not both. Right? Whereas in math, if we say set A or set B, that implies things that are in both as well. Here's the set builder notation. The union of A and B is all the elements that are in A or in B. Okay, so union, the keyword that goes with union is or. Okay, so intersection is and, union is or. And the union is just all of the elements in A, in B, in both, in either. All right, so it's kind of like a marriage, the union of 2 people. You would just throw into that marriage all of the personality traits that A has, the personality traits that B has, those 2 people, anything that they have in common, all of those things are part of that union. All right, and using a Venn diagram, we can show a union. You shade the set that you're talking about, so A union B is all of that part in pink. All right, let's practice finding unions. Here are 3 new sets, A, B, and C, and we'll find all of these unions. Okay, so A union B. All right, so you basically just throw everything in if you see it in A or B, and if it's in both, then you just list it once. We don't list repeat elements. Okay, so 0, 1, 2, 3, 4, 5, all of those came from A. From B, we already have a 2 listed, we already have 4, then we need to list 6, 8, and 10. All right. Often we'll rearrange these and list them from least to greatest, but it doesn't have to be that way. You could put these in any order that you like. All right, A union C. All right, from A we have 0, 1, 2, 3, 4, 5, and then we're going to throw in there everything from C. We already have a 1, a 3, and a 5, so C is just contributing a 7. Okay, and then finally the union of A, B, and C. All right, we throw all of those elements in. Okay, so 0, all of these from A. Okay, we knew that B added 6, 8, 10. That's from our first example here. And then we look for anything new that C is adding. We already have 1, 3, 5, so then we add in the 7. All right. Okay, what about using multiple operations? Well, we do have an order of operations for sets, and just like with order of operations for numbers, you might remember that one, PEMDAS. Okay, this one tells you what order you should do things in for numbers. Okay, parentheses, exponents, then multiplication and division from left to right, addition and subtraction from left to right. All right, so for sets, we also use these parentheses as well to show grouping and to show what you should do first. All right, so when I look at example A, I have two choices of operations. I could do the union first or the intersection, but because the union is in parentheses, that's where I'm going to start. All right, if there were no parentheses, then I would just go left to right. Okay, so I want to start with A union B and then intersect that with C. Okay, so I will start with the union. Let's do that part first, and then I'll come back and intersect it. Okay, so A union B would be element OP, and then the things from B, I already have OP, I'm adding in Q and R, and I want to intersect that with set C, which is R, S, T, and U. Okay, and so I keep going, and you can write another equal sign. It's like a math problem, like if you had 2 plus 3 plus 1, then I would write that that's 5 plus 1, and then I would just keep going and do the next step. Okay, so the intersection of those two sets, look for the things that they share in common. I'll start with the shorter one. Okay, so I'm just going to look in the larger set to see any R's, S's, T's, and U's. Okay, well I have an R, that's in both. No S, no T, no U. Alright, so R is the only thing that is in both of those sets. Alright, so the answer is the set containing R. Okay, how about A intersected with B union C? Alright, so we'll do the part in parentheses first. So this is going to be A intersected with whatever that union is. Okay, so the union of B and C. So O, P, Q, R from B, and then already have an R, and then also S, T, and U from C. And I want to intersect this set with set A, so look for elements that they share in common. And let's see, not L, not M, not N, but I do see an O and a P. So that intersection is O and P. Okay, and then the last example, A intersected with B union C. Okay, so start in parentheses. A intersected with B. What do those have in common? Okay, I'll cross out the things that aren't in B. But O and P are in both A and B. Okay, and then I want to union that with C, which was R, S, T, and U. Okay, so the union, combine everything that's in either or both of those sets. So that's O, P, R, S, T, and U. Okay, and that's your answer. Okay, another example. Let's throw in some complements. Alright, so order of operation for sets. Pay attention to where the complements are. So if you see them, okay, if there are no parentheses involved, then you would do complements followed by intersections and unions. All right, but then parentheses could interrupt that order, and that would always tell you what to do first. Okay, so in the first example, I'm going to do these two complements, A and C, before I do this intersection. That's the order of set operations. Okay, but in the second one, there are parentheses, so I always do that first. So I'm going to do the parentheses, which is actually an intersection, do that first, then do the complement, and then go back and do this intersection. All right, and then in the last one, I do parentheses first. Now inside parentheses, I have two operations. There's an intersection and a complement. So following along with this order, I will do the complement first, followed by the intersection. Okay, so then that takes care of parentheses. Right? Now, that part's done. And now I have two things left to do. I have a union and a complement. So I do the complement first, and then the union. Okay, so it's parentheses first, then complement, then intersections and unions, or you could also do unions and then intersections. It doesn't matter if there's no parentheses. Okay? All right, so let's try these. Again, you might want to pause, try these on your own, see if you can do it, and then maybe use the video as a way to check your answer. Okay, so A complement, how do we find that? Well, we're looking for things in the universe that are not in A. Okay, so I would look at A, look at U, and I'm just going to cross out A from U and see what's left. Okay, well, there's a 20, 40, 60, and 80 that are left. All right, and I want to intersect that with C's complement. Okay, so now I'm going to look at U, and I'm going to cross off all of C's elements, 20, 40, and 60, and see what's left. Okay, so I have 10, 30, 50, 70, and 80. Okay, and then the intersection of those, look for things that they share in common. And it looks like the only thing is 80. All right, so the answer is the set containing 80. All right, the second one. We'll start with the parentheses, and I need to find the intersection of A and B. Okay, so I'll compare A and B, see what they have in common, and I see a 50 and a 70 in both. So that's 50 and 70, that's the intersection. Now I need the complement of that. All right, so now I look back at the universal set and I cross off 50 and 70 and I see what's left. Okay, so that whole first part, the complement of the parentheses, or everything that's not 50 and 70, is 10, 20, 30, 40, 60, and 80. And then I have to intersect that with C, and C is 20, 40, and 60. Okay, and then the intersection, what do those have in common? All of those things, 20, 40, and 60. They're in both sets. 20, 40, 60, in braces to show that it's a set. Okay, so that's the answer. All right, that was a long one. One other long one. B complement, union A parentheses. Okay, so we'll start with the parentheses. Let's find A intersected with C complement. Okay, so we'll do the complement first. So find C complement. Here's C. Look for things that are in U but not in C. So cross those off and see what's left. Okay, so I'm taking A and intersecting it with C complement, which is whatever's left that we didn't cross off. 10, 30, 50, 70, and 80. All right, and if you saved your work from some of the previous problems, like we already found C complement earlier, so that might be helpful to you. You can just go back and refer to whatever that was. So that's another good reason why you might want to show some of your work and the steps on these. Okay, their intersection. Let's see. Okay, 10, 30, 50, and 70. Those are all in both sets. Okay, so that's the answer to my parentheses, but now I need to union that with B complement. So let's find B complement. We didn't do that yet. Alright, so from you I'm going to cross off everything in B. 40, 50, 60, and 70, and see what's left. Okay, so I have 10, 20, 30, and 80, and then I need to take the union of that set with this one, (10, 30, 50, 70). Alright, and I'm going to write the answer up top here. Okay, so just throw all of those elements in together. 10, 20, 30, 50, 70, and 80. And again, I wrote these in order from least to greatest, but you could have written those in a different order and that would have been fine. Okay, so to double check, we did this complement, we did this intersection. Okay, that's here. Then we found B complement, that's here. And then I did take this union, that's this work here, and here's the answer. Okay, we have one more set operation. We have a difference of sets. So this is similar to subtraction. The only difference with sets is that you can't get negative answers. So for numbers, we can do problems like 3 minus 5. Okay, that's -2. But for sets, we can't dip down into the negatives. So we'll do something a little different when we get to that point. Alright, the difference of set A and set B is the set of elements in set A that are not in set B. So basically you're starting with set A, and then you're just taking away all of the elements from B, and you see what's left. Okay, so you're going left to right. So in set builder notation, we're looking for the elements that are in A, but that are not in B. We're taking those away. All right. For Venn diagrams, if you wanted to show this, right, look at the elements in A, you would shade all of A, and then you would take away the ones that are also in B. That's this little part in the middle here. And then you see what's left. Okay, well the pink shaded part is what's left. Okay, so these are the ones that are exclusively in A, not in B. All right. What would this one be? These elements. All right, well they're in B, but they're not in A. So that, in yellow here, this is B minus A. Okay, and you can see that they're not the same thing, just like 3 minus 2 is not the same thing as 2 minus 3. Okay, let's try some examples. Alright, we have sets A, B, and C, and we'll find some differences. Okay, so A minus B is the set 4, 6, 8, 10. And then we want to look at all of those elements that are in that set, set A, that are not in set B, 2, 6, and 12. Alright, so what I like to do is just kind of work with the first set, because I want a lot of them, I just don't want the ones in B. So I'm going to start with A and then just cross off all the things that are in B. I'm going to cross off any 2s, 6s, and 12s that appear. Alright, well I don't have any 2s to cross off, but I don't want 6, and I don't have any 12s to cross off either. Right? So what I'm left with is 4, 8, and 10. These are elements that are in A, but not in B. Okay, B minus C. 2, 6, 12, and I want only the ones that are in there that are not a part of C, which is 8 and 10. All right, well, all of them are not a part of C. Okay, 2, 6, and 12 are in B, but not in C, so it's kind of like saying there's nothing to cross out. All right, I'd cross out 8 and 10 if they were in there, but they're not. So I get to keep all of them, 2, 6, and 12. Okay. How about A minus B minus C? We do the part in parentheses first. All right, we already know A minus B. That's this set up here, 4, 8, 10. So the set 4, 8, 10 minus set C, which is 8, 10. All right, so I'm going to cross off 8 and 10 and see what's left. And the answer is the set containing 4. Okay, and then finally B minus A. So we know A minus B, but this is like the exact opposite. This is all the elements that are in B that are not in A. Okay, so I'm starting with B, 2, 6, and 12, and I'm going to cross off any 4, 6, 8, or 10s that I see. Okay, so there's no 4 to cross off. I can get rid of 6. There are no 8s or 10s to get rid of. So the answer is whatever I didn't cross off, the 2 and the 12. Okay, and that's it for differences. All right, I wanted to do one other example. What happens if you end up subtracting everything from the set? All right, so let's try one more. What if we did like 2, 6 minus 2, 6, 10, 14. What happens if we do that? Okay, well I want all of, let's say that this is A and B. All right, I want all of the elements that are in A that are not in B. So I'm going to cross off any 2, 6, 10s, or 14s. All right, well I end up crossing out everything. So the answer is whatever's left in set A. And if there's nothing there, then your answer is the empty set. All right, so anytime you end up like subtracting everything, you get an empty set. So that's kind of the situation where with numbers, like what do we do about things like 2 minus 5 when we can't go into negatives? All right, well, we can only go down to the empty set. All right. Okay, that's it. So we'll stop there. So in this video, we've talked about the 3 set operations, which are the union, the intersection, and the difference. All right, we talked about parentheses. Those always come first. All right, as well as complements. It's not really a set operation, but we do complements before we do unions, intersections, and differences. All right, so union, your keyword is or. Just throw in all the elements in either set, all right, or both sets. Intersection, the keyword is and. It has to be in both sets. Things in both sets. Okay, union is in either set. And difference is your normal, kind of like a subtraction operation. Subtraction or taking away. Okay, and those are the 3 ways to combine different sets. All right, I hope that was helpful. Try some extra examples from your textbook if you need extra practice or find that to be helpful. All right, thank you for watching.